All right, welcome back for another episode of the Unplanned Show. Excited to have with me April Song from Databricks. We are going to be digging into LLMOps, and so that's a fun one to say. Before we do, just want to cover off on a couple of housekeeping notes. There won't be a show live next week. I'm taking spring break with my kids, but we will be back on April 8th with Aaron Parrott talking about modernizing ITSM. So got to meet Aaron when I was out in London a couple weeks ago and hear him give a talk that I thought he had some really interesting perspective on an area that sometimes feels like a little bit stodgy, but there's a ton of investment in that area and clearly a lot going on. And Aaron is right at the forefront of a lot of that with his clients. As always, you can find the replays, the audio only versions on Apple iTunes, on Apple Podcasts and Spotify. A couple other upcoming things just to bring to folks' attention. Next week, we will have a virtual meetup for Rundeck. So this is the open source process automation, infrastructure automation software that we back here at PagerDuty. So you can go to that rather long URL at the bottom. I'll try to grab that and drop it in the chat. But we've got a couple of users presenting at that, so that should be really exciting. Hans from HBPS Consulting and Diego from Ryanair. And then this is kind of hot off the press, but just starting to let people know we will have PagerDuty on tour coming to a city near you, starting with New York City on May 22nd, going to San Francisco on June 11th, and then London on June 27th. Dates to be set for Tokyo and Sydney soon. So all of that in your calendar. You can go to pagerduty.com/on-tour, much easier URL to remember. With that, let's get into the topic of the day. April, you and I actually go back, I don't even know how many years, but maybe like 8 at this point.
Yeah.
When you were a data scientist on the team at Pivotal, which was a really fun experience to be able to that was the first time I got to work alongside a team of data scientists, and it was so impressive, and I learned so much just getting to pick y'all's brains and hear about all of these kind of emerging techniques and how they get applied in business contexts and sort of building the experiences that people want to build. And then fast forward and, here we are kind of meeting again a couple months ago. And you're now with Databricks. I'm now with PagerDuty. And at the same time, this whole world of generative AI and large language models is coming up. But, this kind of question of like, oh, right, there's one thing to build with it. It's another thing when you put it in production. So that's why I love kind of taking the ops side of it. So love having you on to just share with us. So let's start with just the baseline question of kind of defining like, what is LLM ops? There's a lot of things people put something ops. Let's just sort of level set with the audience. Break it down for us.
Yeah. So what is LLMOps? You know what? It's a fancy term for, a set of practices, processes, people, culture, really aimed at managing large language models and applications that are developed using large language models. And so I'd say it's really like an extension of MLOps or machine learning operations, which is also an extension of DevOps. I would also, you can think of, ML, LLM ops as kind of 3 categories. There's, I'd say, data operations. So making sure that you are versioning your input data, your feature tables, for example. There's model ops. So that was new, I think a newer concept that was introduced as machine learning operations started to become more mature. But that is really around how do we start managing at scale machine learning models through its life cycle. So from like a experimentation phase to production deployments all the way through archiving. And then the third area, which is I think maybe the most important part, is DevOps, which is really managing the code that produces the models and the outputs, right? So not only are we having to version the machine learning models as we are, for example, retraining them, but we also want to make sure that we're versioning our code and all of that. So there is still a very typical CI/CD process at the core to help with the code quality there.
Okay, I've never heard that breakdown before, but that's super helpful of the data ops piece, the model ops piece, and the DevOps piece, and how they all
Hmm.
have to come together for really any of these kind of AI, machine learning, and LLM just being kind of the hot term of the year. Um, but that's a really great way to break it down because, it's a complex layered problem that's not just about code. The data is so critical. And I think a lot of
Yeah.
people maybe aren't familiar with, like, on the model ops side, like the fact that models have a life cycle of
Yeah.
their own. And is that something that you've seen change as data science has kind of like expanded, I'll say, and not shifted? Because I think
Hmm.
it's really an expansion as opposed to any kind of shift from like a um, more of a deterministic model to some of the models that end up getting built for um, the sort of generative AI use cases. Has that life cycle evolved, or is there a sort of pattern that we've learned from kind of a deterministic time that continues to
Hmm.
be really important?
Yeah, so that's a really great question. There's definitely some patterns from the more traditional ML development workflow that we can still leverage. So in terms of like now when we think about a model in terms of Gen AI applications, it's no longer a traditional I am training something from scratch. Typically, for example, if I am building a retrieval augmented generation app, there's no training stage involved. I'm using an off-the-shelf large language model. I'm creating a prompt and sending that prompt with some additional data I'm retrieving as context to the large language model, right? But so with this architecture now, you have the concept of a prompt, and those can change really fast. And so
Mhm.
now so now you want to think about, okay, how do I guess a model here is defined as a combination of a prompt and a large language model. And that gives you the answer. And to your point, it's non-deterministic, and so you're not going to get the same answers each time. So that's another piece you want to start thinking about is when it comes to quality monitoring. It can be a lot more challenging to monitor generative AI applications as opposed to more traditional ML models, where you have deterministic outcomes, right?
Yeah.
So yeah, so I think right now this field is evolving. There's still new tools that are people are working on to improve this. I'd say it's still a new emerging field.
Okay. One thing I wanted to understand, and I've
Hmm.
looked at, like there's kind of a great diagram that Andreessen Horowitz put out last year of an LLM architecture, and of course, even that I think has probably evolved because we're starting to see, at least I'm hearing more about, smaller models and how those can start to be applied. Um,
Hmm.
so the architecture isn't even like calm down, right? It's like it's
Yeah.
still pretty hot and changing space. But
Hmm.
I'm just curious, what are some of the different ways, doesn't have to be exhaustive, but what are some of the ways you can see things going wrong in that LLM architecture? You just
Hmm.
sort of described the, retrieval augmented, the RAG architecture, which I'm not even sure I can
Hmm.
remember all the words, but, um it's a different architecture. There's a lot of
Hmm.
interdependencies between different different components that are doing different jobs.
Yeah.
Where where do the problems tend to crop up? What are the things that, like, people kinda need to know when something stops working and it's gonna affect that output, but not because it's a non-deterministic model, but just because something else in that pipeline went wrong?
Something went wrong. Yeah, it comes down to making sure you have a good way to set up observability and monitoring throughout your entire pipeline. So you asked well, let me start first by saying when we think about generative AI applications and building them, there are, about like a few different patterns. So RAG is just one pattern. So that has like one architecture, underlying architecture. But lots of people are also fine tuning existing models. So that too is another kind of approach in that case, very different from RAG. But the idea is the developer workflow is the same. I'm developing something, I have to test it, make sure the quality is right, and then there's a process of deploying it. So what could go wrong here, right? Once you start working with large language models, application development becomes more complex. You're chaining together a bunch of different components, and oftentimes you might even be calling a large language model multiple times to complete different tasks. And so being able to monitor each step in that task, I think, is important, so that you can start to trace back and understand where in my chain of logic did things go wrong. So without proper monitoring, for example, you could release a chatbot application and unknowingly be releasing sensitive information about customer data, for example, because you didn't have the right guardrails in place and you didn't have a monitoring framework that is then validating the responses that your service is sending out. So those are, some examples where things can go really wrong and silently fail. And so it's really important to have a monitoring framework up front before you actually go through the process of a full production deployment. Because once you get to deployment, how are you going to catch those silent failures? By the time an angry customer reaches out saying, "Hey, why was my data exposed?" It's a little too late. So you need to make sure you have those guardrails.
Yeah, I think that concept of failing silently, right? Where there's no obvious, we're way past the days of like the Twitter fail whale as my favorite
Yeah.
example of like very unsilent ways to fail. But yeah, so just tell me a little bit more about, what does that mean in these types of architectures? You mentioned a couple already, but just hearing it another way, like there's so many different layers to like how you successfully operate a large language model in production. Um, Tell me more about the silent failures.
Yeah. So I want to start first by saying, like, why is this really important, the silent failures? So quality is really important for building RAG apps, because I'd say for an end user to adopt what you are building, they have to trust what they're
Mhm.
getting out of it. And so the minute you get a wrong answer, you probably don't have time to give feedback and say, thumbs down, this didn't work. You're going to move on and go continue looking for your answer, go to a different search bar or something, right? And so oftentimes you might not even get that feedback that your model's doing poorly,
Hmm.
because your end users aren't giving that to you explicitly. And so again, it's really important to make sure quality is good and that you have a mechanism to monitor that even when users aren't telling you. Otherwise, you won't know if there's an issue with the product or why your users aren't adopting it to begin with. So I think your second part of the question was, in practice, like how do we actually go about implementing this and making sure we prevent silent failures? Right now, I'd say it's a lot of rounds of testing. So I know companies have teams of humans actually evaluating the output, and I think that is going to be. We are going to have human in the loop evaluating the outputs of our applications for some time, and so that's been a common pattern that I've seen, is that there's now like a central team and this testing staging process, if you will, here is a little bit different in that now you have to have a team of people searching through and reviewing answers to then actually validate the output. And some of that can be subjective as well, right? Like how good is this answer? How comprehensive is it, for example?
Yeah, and I can imagine like depending on what you're trying to build, like needing those folks to be potentially domain experts if it's a really targeted use case for
Mm-hmm.
certain types of users, and not necessarily kind of generic, like this looks good, or that was accurate, for what a kind of an average kind of consumer would be able to verify. What are some
Yeah.
of the other things beyond like quality, like
Mm.
going back beyond it, just on like the pure output from the model? What are some other ways that things can go wrong?
Yeah. So so oftentimes if you are developing against open like a SaaS provider of large language models, so Azure OpenAI, for example, they could, make changes to their models without telling you and make an update, in which case you don't know that your application's been impacted from that update.
Hmm.
And so suddenly the output of your answers start changing. If you've played around with like prompts a little bit, you can understand like tweaking a prompt a little bit or tweaking like the underlying model can change the output quite dramatically sometimes.
Mhm.
And so there's been examples too where like you build something using Azure OpenAI and you release it, and then they make an update to their models, and suddenly the output that your application is returning is no longer making sense, right? And so because you have dependencies on other tools in the ecosystem, there's more areas and room for things to go wrong. And so that's where I think LLMOps is now just becoming more and more important, and people are figuring out, trying to find like what is the best way to design a system here so that we can properly handle these dependencies. And actually, with like this particular use case, right? The only way to make sure that you have control is to like actually own a large language model yourself, or have more control over what you're building. The fewer dependencies you have on these external tools, the more control and, honestly, like I'd say, end-to-end observability you'll have as well.
Mm. So tell me a little bit more about
Mhm.
that because it definitely it in the last year, I'd say like going from that being a maybe daunting proposition of, you're going to have to maintain this yourself. What's changed that maybe is making it more um uh feasible for organizations to run their own large language model or smaller models that they can fine tune with more precision for their use case.
Mhm.
What's kind of changed there, because and I think it was pretty daunting a year ago.
Yeah. So I would say technology has just changed a lot in that LLMs are so powerful, and we now have different ways to expose or democratize AI for people, that you no longer need to understand like how to train an LLM model from scratch. You can just start using one, and you all you need to know is how to write a prompt, which is a set of instructions in English, and send that to an API call. And so I think what's really awesome about this space is that you truly no longer have to be a traditional data scientist, learn how to go train a classification model, for example. You can now just use a large language model, give it a prompt to classify something with a few examples, use zero shot or a few shot prompt learning, and get that. And so a lot more people have access to building applications with this without having to go get PhDs, for example. So I
Okay.
think, mhm.
Yeah, that I hadn't really that was something, yeah, that I don't think has kind of come to my attention, right? About just how like the actual techniques, the prompt engineering techniques, like, few shot and whatnot, are part of the ways that you can actually train the model over time. Am I saying that right? Is that fair?
It, it's more like it removes the need to even like train a model, because sometimes,
Okay.
so here's an example. I want to build a chatbot that answers questions, but there's only a few set of questions I want to choose from, because they're like data questions and they need to be exact answers, and I want to just fetch a query for that, right? And so in a case like that, I can have the first step would be, okay, user asks a question. I need to map that question to one of the set of questions I have an answer for. How do I do that translation? Typically, that would be like a multi-class classifier. You could go train a model to predict, okay, given this sentence, which one of these questions is it asking? And when I say question, it'd be like a question ID, for example, if you can imagine. But now, instead of having, training a logistic regression model to predict that, and then that itself goes through a whole MLOps life cycle. So that's something you have to
Mhm.
think about setting up as well.
Okay.
Instead, you can use a large language model to classify input text for you. So you can tell your model and say, hey, your job is to classify this input into one of these four categories. And then you say the four categories you want to provide. And then you can maybe add some more additional information about those categories to help it. And then the model will give you a prediction of which category it belongs to and even a score. And so that just saved you a few weeks from having to train a model on your own to classify something that you need for a larger problem.
Yeah.
And then again, like I said, that you no longer have to go through the whole, I have to go deploy this thing now, get this all set up tests, none of that. And then also, as you start to say in this classification problem, the thing you're trying to classify, say the number of labels changes. So I want to add like 100 more questions to the set, for example. Traditionally, you'd have to go and retrain a brand new model and say, okay, now there's 100 new classes, go through the whole training process again, go through the whole deployment process again, and then go test it, right? But in this case, all you have to do is tweak your prompt and just add those additional categories to your prompt, and that's it. So your LLM will now understand that, take that context, and be able to give you, be able to classify something for you. So
Yeah. Okay, that's huge. Thank you for explaining that. So I think like coming back to this notion of how it's really democratizing the whole process of building with AI, right? You don't have
mhm.
to be a PhD data scientist. Um, so, you know, as this kind of accelerates how many more folks are then building with it, kind of coming back to the LLM ops
Yeah,
side of things,
yeah,
right? Is like, okay, I always think of like squeezing the balloon. And greetings to our four-legged friend also joining us on the show today.
unplanned.
Very sweet. Um, but yeah, so what are your thoughts there in terms of like, okay, is this introducing any new challenges in terms of, okay, it's in one ways it's great and it's going to unleash a lot of creativity and a lot of
Mhm.
ideas that can get explored. But there's usually always kind of a little bit of a trade-off or something else that kind of needs to catch up, a new muscle group that needs to
Mhm.
develop, particularly on the operational side, in order
Yeah.
to handle, whether it's a lot of new code getting introduced or new applications getting introduced or new changes or whatnot. So yeah, just curious, kind of like what are your thoughts there?
Yeah, I mean, absolutely. I think with great power comes great with
Yes.
great power comes great responsibility. So, yeah, I think now the fact that like more people have access to this, it's, there's even more, it's even more important that we have LLMOps practices defined because you want to make sure that there's guardrails in place during every step of that development. A developer might not necessarily understand what data was used to to train a foundational large language model or how it works. So that oftentimes informs how you create your prompts or even how you approach a problem,
Hmm.
right? And so if you don't know these things, you don't really know the direction to go towards when you're solving a problem. So for example, if you are familiar with this space, you know that ChatGPT was, trained with data from all over the internet. But if you are building a, medical application, do you need to have a model that's bloated with all of this other data that's not known, that has nothing to do with healthcare data, right?
Right.
In that case, it might make more sense to make an investment and, fine tune your own model with your own proprietary data. But with someone who has never really worked in this space before, be able to kind of reason that out and understand, okay, actually using an open source LLM might not be the best for my use case. I have all of this proprietary data. How can I leverage that? So it's really, I think it opens the door for a lot of automating a lot of easy tasks. But when it comes to actually solving harder problems, I think that will still require a lot of like domain expertise, and people are still figuring things out today. Like I'd say there's lots of examples of how to put together a Q&A chatbot with some data, right? But how do you actually do this at scale? And how do you actually, do this for different domains of question Q&A bots, right? So within an organization, there's tons of different use cases for Q&A bots. There's, can you build one for HR? Can you build one for engineering teams? Can you build one for XYZ use case? And so it's like taking one pattern and then figuring out how do we scale that out to support all of these other business use cases. And then also making sure like that is worth the investment of developer hours and all the costs that it's going to take to potentially serve what you're building, right? I think a lot of customers or a lot of people are still in this place where they're not sure like how much value can I get out of what I build today with Gen AI, and it really depends on where you start, I guess.
Gotcha. This kind of raises another question for me, which is kind of like whose job is LLMOps anyways?
That is a very good question. And I hate to say it, but it is just going to depend on where you are, your current state, and some of it comes down to leadership too, and how big your team is and scale. So if you're a smaller, scrappier company, startup, you're probably going to have to do everything yourself, be a full stack data scientist. No, you're going to have to understand all the traditional data science ML theory, but also be able to deploy applications, understand what it means to go through CI/CD, and then also set up observability and monitoring. So it can be a lot. I think that's really the friction a lot of companies have is they just don't have the skill sets to do it all.
Yeah.
There are other companies that are more mature that are able to have centralized teams to manage this. So oftentimes, if you do have a central team that is building a central ML platform or LLM platform, then they will also own the process of defining and implementing the MLOps or LLMOps practices on that technological platform, right? But they also have to educate the users on how to adopt the processes too. I think that's also a big challenge, is getting people to adopt the processes, because at first it could seem like it's slowing you down because there's all of this new process you need to do. Like, oh, now I have to go open a pull request, and now I have to, set this up, make sure I'm logging this. But you'll see after the first iteration, making updates and changes to your models becomes quicker. Iterating becomes much more like way faster, and so you see the value of having these guardrails set up. So it depends. You could have a central team managing it too. I think what you want to avoid though is having a situation where you have one team developing a model and all they do is just hand over their code to a different team that is then responsible for operationalizing it. Because then there's a lot of time just wasted on taking someone else's code and translating it to a deployed model, for example. And so MLOps really came about because that was what was happening originally. Here's my code, here's a notebook. Engineering team, can you go deploy this as a REST API? Because data scientists didn't know how to set up a REST API from their model. But again, with like new tools today, it's made that kind of deployment process and handover much easier, that you don't need all these different, I mean, you do need different roles, but the communication and collaboration between the different roles is much smoother. They're able to use the same tools. And again, like ultimately it requires a lot of different teams to put together a production quality application. So uh, teamwork is very important there.
Yeah. I think that's a great call out to sort of, I mean, what it sounds like is just like, don't slip it back into those patterns of, I mean, with developing any code and throwing it over the wall for a different team to figure out how to put it into production. That's, um, I feel like a hard learned lesson across the software industry. So great call
Mhm.
out to just remind people, like, just because this is a different type of application doesn't mean you just go back to that old school way of approaching it. Um,
Right.
I wanted to also just kind of step back and see, it's a fast moving space. So curious, like, what's kind of some of the recent developments with LLMs that have you excited?
Yeah, I'm most excited about like where industry's going this year and how people will start to leverage their own data to build Gen AI applications without having to send it out to external tooling. And so really that means, there should be, you know, technology that will enable people to start building a lot more of their own custom applications, but within their own infrastructure,
Mhm.
with their own data, and using like an interface that is easy for people to learn without having to go through a whole machine learning boot camp or LLM boot camp to get the basics. And so I'm really excited about what companies like Databricks is doing in the space, in the RAG space, to help people build Q&A chatbots, because that is like, I think one area where a lot of people could benefit from. Like you are probably pinging people all the time, asking people for questions, and then people are like searching that information somewhere. It's in some knowledge base, but it's just so much time spent asking questions around and searching, right? And so if we can enable companies to quickly and build these applications, but also know that quality is important. So I think there'll be more tools around being able to monitor and monitor quality of the output, and also automatically use uh, responses generated to improve the original application itself. So, for example, there might be common user questions that are being asked that your system can't solve for, but you are logging that, and so having tools that are able to automatically detect, in this case, new questions that are commonly asked, and add or find context to answer those questions and update that. I think people are working on tools to help automate the prompt generation there. So really excited for what's happening in that space.
Yeah, I mean, you're bringing to mind like a lot of use cases that hadn't I hadn't necessarily considered, but you're right. So much of it requires being able to train a model or have a model that's um, using your own data, and that just seems to that has been a little bit of a barrier for kind
Mhm.
of opening up just a ton more use cases. But yeah, it sounds like there's also just going to have to be probably some shifts that teams have to make to think about how are they structuring their team to be part of that human in the loop quality control. Just imagining, right, like the internal Q&A chatbot, if someone is part of that, they're sort of being augmented by the LLM. in that
Mhm.
response, but they're qualified to review that and know, like, yeah, that's the right answer, or no, that's not. Um,
Mhm.
then it's still more efficient, but there's still like you can't fully get out of um, the loop, right?
Mhm.
I don't know if you're seeing anything early in terms of like what looks like healthy patterns emerging for how teams across lots of different domains are participating in that operational side of these assistive tools like Q&A chatbots that are like, yeah, over time, this is going to cut down on the number of interrupts we get, but we've got to sort of work with the LLM at first. Is that how folks are approaching it or not?
Mhm. Yeah. So, so there's like I know a lot of companies are like outsourcing a lot of the actual like human validation of some of the outputs. But I would say what is also important too is a lot oftentimes in these Q&A chatbots, you're retrieving documents from internal documents uh, that are probably already contain the answer. So I have a question about like how many vacation days can I take off, stored in some HR policy doc somewhere, right? And
Mhm.
so if we are able to get good enough answers, but be able to craft a response where we are also showing references and explaining like where those answers were generated from or where you can go find that answer and providing a link, for example, that will also really, I think, help accelerate adoption of these types of applications by people because
Mm.
it'll give people more trust. It's like, oh, you're telling me, I have unlimited PTOs, but I don't know if this is a hallucination or not unless it is citing some references, right? So if it's able to point, say, hey, you have unlimited PTO and it gives me some extra information. Here's a link where you can go see the actual doc,
Yeah.
right? That would make users trust your answer a lot more. And so I think in those cases, hopefully like having human in the loop isn't as important as critical of a part there, but thinking about how can we make sure users trust the output we're giving is also a key part.
Yeah.
Mhm.
Um, okay, just want to squeeze in just one more question. If there's anything we didn't touch on that you're like, Dormain, you missed this really juicy question. Um, any final thoughts or anything we didn't touch on that you think is really important from an LLM ops perspective?
Yeah, well, I'd say like it starts I would say try to find a commonality around all everything you're developing in terms of data science, machine learning, and LLMOps because things are always going to be changing. There's going to be new there might be new patterns in a couple of years, right? So being able to have a foundation when it comes to some sort of operations um, is a great place to start, and that often time starts with defining an end-to-end developer workflow. So what does it mean to take a business question and turn it all the way into a final production product, right? So there's a development life cycle. So what
Mhm.
does this data science do? Um, and there's a lot that goes into it before you're actually ready to say, hey, I'm ready to go deploy this model, right? So making sure, like my recommendation would be have a framework defined to help you move through those different stages of the life cycle because that is oftentimes where people I see a lot of organizations struggle is that they just don't have a process defined to start they have they have some folks who know how to train a model, they have an engineering team who build applications, but there's really no intersect. So really taking the time to put together a team and understand like what does that end-to-end development lifecycle look like in this specifically for gen AI applications and um, machine learning models. It's
Okay.
going to be important if you want to be able to scale that in the future.
Yeah. Okay.
Mhm.
That's a great call to action for folks on, you know, defining that end-to-end workflow, and even into to day two, right? As things are going to change, and then yeah, pull in folks who have the expertise, even if it's not end to end, but have them work together to define like what that end-to-end workflow should look like. That sounds like a great next step for a lot of folks.
Yeah,
Um,
it's cross collaboration,
yes.
definitely. Like you need your CI/CD team to talk to your, Gen AI team to understand what does CI/CD mean in their use case. You can't just force, your data science LLM teams to use what some other engineering team has already set up, right? The processes and problems are not the same. So be ready to embrace change and support that. Model quality, that's
Yeah.
a big one, right? That's something you don't really think about when you're developing more traditional web applications. There's no like data quality kind of aspect to it as you would have with a machine learning model. So,
Yeah. Okay.
mhm.
All right. Well, thank you, April. This has been really helpful for me, and hopefully helpful for folks who've been tuning in. So I want to thank you again for taking the time, and for folks for watching and listening to the audio podcast. Have
Yeah.
an uneventful day.
I want to thank you for having me on the show
Yeah.
and great seeing you again.
Yes, absolutely. Looking forward to more. Okay.
Bye.